Hi, this is Hai Xiaowang, and today we're going to talk about the game of life. And given the board n by n grade of the cells, which uh, uh, which which has two state, live or dead, and live represented by 1 and dead represented by 0. And there are several rules about how the game works. So basically, it means that if the original state is live, only if its neighbors' lives equal to 2 or 3, that in the next stage that state will continue to be live, and if not, it will be dead. And for the current status is that only if its neighbors, the number of the live neighbors equal to 3, the next state will be live, else it will be dead. So actually the most difficult point in this problem is that the next state is should be created by applying the rules simultaneously, which means that we cannot change the current state one by one. So, which means that we should store the state in some form, and there is a root solution to this problem, which is created by n by n, which is the same size as a board. However, actually we can make full use of this board, which means that we can store some informations in the array numbers in the grade. For example, we assume that a number in the grade can be composed of by some binary numbers. For example, if the grade value is equal to 2, which is just equal to binary representation form like this. So actually we can store the informations in some digit, and that is the most tricky part in this problem. So by using this kind of the trick, we can only use one big O of one space here, which is optimized from n by n to 1, which is a great improvement. And the basic idea is that we just go through every cells and check the number of the lives of its neighbors and do something and to check and to get the next state of the current cell, and store that informations in the second digit of the integers in the grade, and then we just use bit operations and get the result of the board and update it in the board, and that will get the result. So let's just code up. So first we just get the shape of the board, and then if m is equal to 0 or n is equal to 0, which is the corner cases, we change just the return. And it goes through the every cell in the board, and we initialize the life should be 0, and for oops, sorry about that. Let me write this first and then explain. Actually, this is just go through its all the neighbors of the cell that we are currently enumerating. And I use max for the minimal range, which means that we should there is some possibility that I -1 or j -1 is less than 0, and which is out of the boundaries of the grid, and we should prevent it from happening. And so we just get the maximum of the 0 and with these two values, and the same here for the maximum range. And so this is basically go through its neighbors, and we just if the board RC is life should count +1, and this is also a bit operations, and which means that we only look at the first digit of the board. For example, if it's a 2, and which is 1 0, and we just only look at the first digit. And this is because we only store the next informations in the second digit, and we should not take that into consider. So, and initialize the next state to be 0, and if the board ij is equal to 1, so because we already take it into consider, so we should minus it. And if the life is, and according to the rule, is equal to 2 or life equal to 3, we just return, oh no, sorry, it should be 1, and else if the current state is that, and if life is equal to 3, and next should be 1, and we should update, we should store the next state information in the second digit, which is and out of that, we just go through its array neighbors and move the second digit to right, and which is updated informations. And for this line of the code, which means that we first move the next status left move a left and keeps the first digit to be 0, which means that if the current state is 1 and we move 0, we got 2, and this means that we compare the corresponding digit of these two values, and if one of them is 1, it will result in 1. So if this is in 1, because the initial integers only have one digit, so it just means that if the next is 1, and it will return a result in 1 in the second digit, so we can store that information. So let's check whether it works. Yeah, it seems to work. That's pretty much about the problems. Thanks for watching.